the final. I just have different numbers. So the very first problem, there's one similar to this. This is an equation. And if you guys have an equation, what I would really, really recommend is, especially if it's complicated on the bottom, I would work to find a common denominator between all the fractions that you have in the equation. So to work with that, if you can factor anything, that's what I would recommend that you do. So you can't factor anything with x plus 4 or x minus 4, but I can factor x squared minus 16. That's called a difference of squares. Does anybody remember, like, could you tell me the two little parentheses that would go with x squared minus 16? X plus 4 and x minus 4, doesn't matter the order that you put them in. Okay, so really the bottom of that fraction that this is equal to has one of the denominators from each of the other two fractions in the problem. So this is nice for us. So I'm just going to create a common denominator. Sorry guys, I should have left a little more spaced out here. But what I would need on the top and bottom of the first fraction would be x minus 4. Whatever you do to the top, you have to do to the bottom. So that way we're really multiplying by 1. And I already have an x minus 4 in the second fraction, so to make it match over here, I need an x plus 4. And if you do have an equation, this does not work for an expression, but if you have an equation where we have an equal sign, we're going to add these two fractions together, set equal to the fraction on the other side. I created a common denominator. If you make a common denominator between all the fractions in an equation, you can literally just remove that and work with the numerator. Okay, now I'm going to write this, but you could really probably do this faster than what I'm going to do here. So on that first fraction, the numerator, I'd have 1 times x minus 4, and I'm adding those two fractions together in the original problem. The numerator of the second fraction, to create our common denominator, we're going to do 1 times x plus 4, and then on the other side, I didn't have to manipulate that fraction because it already had that denominator, so it's already going to match up, so that's just going to be an 8. Now, if we had numbers here, this would alter this a little bit, but if I just distribute a 1, this is just going to be x minus 4 and x plus 4. So combine your like terms here. Actually, you have a negative 4 and a 4. They'll cancel each other out, and you're going to get 2x equals 8. So then we can just solve that real quick. We're just going to divide by 2, and x would be 4. Now, if you do have a rational equation, you got to make sure that your answer is not going to cause you to divide by 0. So just before you choose that as your answer, because these will be multiple choice, and I guarantee that will be one of the options, you got to ask yourself, can I actually use this as a solution to this original problem? The whole thing's multiple choice, yeah. What do we think? Is this an answer I can use? Okay, you guys remember, you can't divide by 0, right? So if I plug this in, and it only has to be one place, but if I plug in, let's see, where would it go? If I plug in 4 to x minus 4, either one of those places, that would cause me to divide by 0. So this is actually like an extraneous solution, and that's the only answer we got. So that means if that doesn't work, then this equation has no solution to it. So you just got to check. The problem numbers here, if I had gotten 4 or negative 4 as an answer, that would cause the denominator in the original problem to be 0. If I'd gotten any other number, it would be okay, but because I got 4, that doesn't work because it causes us to divide by 0 in the original problem. So my answer there would actually be no solution. Okay, so we'll review with that. Now, I got a complex fraction in the second question here. So I know this looks really garbagey, but I would just deal with this almost like it was two separate problems. So let me just look at the top of the fraction. Okay, now if you do add or subtract fractions, you have to have a common denominator. So if I'm going to try and subtract 6 over 4x minus 2 over 3x, what would you use as a common denominator between 4x and 3x? 12x. Okay, so we're just going to manipulate this so we can get that going. All right, so to make it 12, let's go 3 top and bottom of the first fraction, 4 top and bottom of the second fraction. Whatever you do to the bottom, you got to do to the top, because that way we're just multiplying by 1. So I would have 18 over 12x minus 8 over 12x. Okay, now we don't want, I know those both can be reduced, but we don't want to reduce because we're trying to get a common denominator. So I'm just going to go ahead, subtract that right there. When you do subtract, the denominator stays the same. You get that common denominator and you keep it. You just subtract across the numerator. So 18 minus 8 would be 10. And I know that reduces, but for the moment, I'm just going to leave that alone. Okay, now I'm just going to look at the bottom of the fraction only. So I'm going to try and add these two fractions together. So I've got 3 over 7x plus 2 over 21x. What would I use as a common denominator between those two? You're going to multiply by 3. If you just, and you don't even have to do it to both, just multiply first one, top and bottom, by 3, then the denominators will both be 21x. Okay, let me come over here and write this. So I would end up with, let's see, 9 over 21x minus 2 over 21x. I don't have to manipulate that second one. And that got my common denominator to be 21x. 9 minus 2, I'm sorry, plus is, I'm sorry, this is a plus. 9 plus 2 is 11. Okay, so once I did my simplification of the top and the bottom, then this is really my problem. So if I divide a fraction by another fraction, it's the same as multiplying by the reciprocal. So I'm just going to keep the original, and I know you can reduce it, but I'm just going to reduce it at the end. So keep that 10 over 12x times, so change that. I'm going to keep that, change that, and I'm going to flip over the 21x and the 11. That gives me the reciprocal. And if you are multiplying fractions, you do not need a common denominator. We're just going to multiply straight across the top, straight across the bottom. So 10 times 21 is 210, and that would have an x with it. And then across the bottom, sorry, I got to grab my calculator, 12 times 11, 132, that also has an x with it. Now, we got a product on the top, product on the bottom. I have an x in the top, x in the bottom, so those just actually go away. All right, and then all we have left to do is just see if we can reduce that fraction. So I'm just going to grab my calculator real quick and cheat here. I'm going to do 210 divided by 132, math, enter, enter, and this reduces 35 over 22. And that's how it is on the final. The answer to this particular type of question that you're going to see will be a fraction. So. And that's not exactly the nicest fraction in the world, but you can always use your calculator to help you reduce. Is anybody having a question? All right, number 3 here. So this is just a quadratic over a linear expression here. It just says simplify the rational expression, state any restrictions on the variable. Remember, you have to have product to multiply. So if I have all this adding and subtracting, I don't want to just cross stuff out. And I'm going to see if I can factor the top. So the top of that's a quadratic, and it is factorable. The bottom of that's just a linear, nothing to factor there. X and 2 don't have anything in common. On the top, though, can you think of two numbers? If you'd multiply them, you'd get negative 14. The same two numbers would add to get negative 5. 7 and 2. Which one has to be negative? 7. Okay, so one of these is x minus 7. One of them is x plus 2. Doesn't matter the order. Okay, now, because I have a product on the top, now I am allowed to cross off anything that matches. So I have an x plus 2 on the top, x plus 2 on the bottom. Those are going to get crossed out. My actual answer, that'll just actually get rid of the fraction there. So I'm just going to have x minus 7 as my answer, no more fraction. And it does say state any restrictions. So for your restrictions, what number can x not be for that problem? Wrong. Negative 2. Okay, you just can't have the bottom be 0, and I know that's weird because the bottom actually canceled, but it's at any point in the problem. If something you plug in would cause the denominator to be 0, you got to exclude that. So the only number that's causing us a problem there, if I have x plus 2, negative 2 plugged into that would cause that denominator to be 0. Okay, now this question right underneath here is also about restrictions, and you'll see a very similar problem on the actual exam. So it's not going to actually ask you to do the problem, it's just going to say what are the restrictions on the problem. So we're just going to list these out. Okay, restrictions come whenever you have something in the denominator that could be made 0. So if you've got an x somewhere in the denominator, we got to exclude that. So this very first one, I've got in the bottom of the fraction 4x minus 3. I just kind of do this in my head, but if you don't want to, if you want to kind of write it out, you don't want that to be 0. So what you would do to get that restriction, we would add 3 there and divide by 4. So I do not want x to be positive 3/4. That would make the denominator in that first fraction 0. What would make the denominator in the second fraction 0? 2. Okay, so there's another restriction. Now, this is the tricky part to this particular question. Okay, this is a division problem, all right? So if we were to actually go through and do the problem, which I'm not going to do, but if we were to, we would keep this original fraction, we would change that division to multiplication, and we would flip that second fraction over to multiply by the reciprocal. When you do that, that takes that second fraction and introduces another term into the denominator. So that's going to add one more restriction in that case, which if this is x plus 9, negative 9 is now also going to be a problem for us. So if you do a division problem and ask you for the restrictions, the first fraction they give you, you just worry about the denominator. The second fraction, whatever you're dividing by, you actually have to do the numerator and denominator, because the original problem, I wouldn't want 2 to be plugged into the denominator. When I flip it over and get the reciprocal, now I don't want negative 9 to be plugged in. So there's 3 restrictions there. Is anybody having a question on that one? Okay. Now, and I'm not joking, there is actually, I feel like this is more of an Algebra 1 problem, but there is an actual just proportion on the final that looks just like this. There's nothing squared, there's nothing to factor, just 2 fractions equal to each other. I would just cross multiply here, and when you do that, just be careful if you got 2 terms, you just want to put them in parentheses. So I would just have 2 times x minus 3 on one side equal to 6 times x plus 6 on the other, and then we're just going to solve that real quick. Little distributive property, I'm going to get 2x minus 6 equals 6x plus 36. And then however you guys want to solve it, if it's me, I do like to try to keep my variable positive if I can. So if it was me, I would subtract 2x from both sides. And just to save myself a little bit of space, I'm going to do this in the same step. I'm going to subtract the 36 here too. All right, so what I would be left with then would be negative 42 equal to 4x. Now, in terms of what numbers would cause us a problem here, if I got negative 6 or if I got positive 3 as an answer, we wouldn't want to use those. But if you divide this here, this is actually just negative 10.5. And that's not something that's going to cause the denominator to be 0, so that would just be my answer for that one. Anybody having a question? All right, number 6. Now, this is not an equation. Not an equation. This is just an expression. So, if I do want to add fractions together, which I want to do here for this problem, I do have to have a common denominator, all right? So, what I would, sorry, I should have spaced this out a little bit better. Let me ask you, I'm just going to leave a little space there. I can't factor anything in that first fraction. I can't do anything with, I can't reduce anything either because I have addition on the bottom. So don't like reduce that 12 and the 8, doesn't work like that. Can you factor x squared minus 64? So multiply to get negative 64, add to get 0. What would you write? Perfect. So x plus 8 times x minus 8. All right, now, if I'm trying to get a common denominator, what am I missing in the first fraction? Or what do I need? X minus 8. So we're just going to multiply top and bottom by x minus 8. That'll create a common denominator. Okay, now, this is not like the problem at the top of the page. This is not an equation, so don't cross the denominators out. What we want to do here is we're going to add these together. So I got to do just a little simplification. I'm going to distribute a 12 to this x minus 8. So 12 times x would be 12x, and 12 times that negative 8 is negative 96. Now, I've got a common denominator, so I can just go ahead and add the 5. All right, and when you guys see this in the multiple choice, they're going to leave that denominator in factored form. So I'm just going to go ahead and do that. Really, in this problem, the only other thing I could do is combine the negative 96 and the 5, which is going to give you negative 91. Now, if I could in any way factor the top of that, I would try to do that and see if anything else canceled out. But in that problem, like 12 and 91 don't have anything in common, so that's just going to be my answer. And you want to go ahead and just leave the bottom in the factored form. That's how it'll be in the multiple choice options when you see that question on the final. Okay. Now, oh, this staple level really came out here. This one I think is probably, out of this whole section, I think this one's probably the trickiest problem that you'll have to do. And it's very, very similar to this, just different numbers. Okay, so if you have this is back to an equation, not an expression. This is an equal sign. All right, what I would tell you to do here, sorry, I should have spaced this out. I'm just going to make a little space so I can go ahead and create a common denominator here. What I would do, let me take on the side where I just have a plain 3, I'm just going to write that as 3 over 1. Okay, now, this is the main thing I think people mess up on this type of a question. So I have an x plus 2, and they'll just be like, oh, I just need a plus 2, and they'll just add 2 to the top and bottom. You can't do that. It has to be with multiplication. So if I try to create a common denominator here, I need to multiply this by x plus 2. You can't just add something in. It has to be with multiplication. So that way I have to multiply, or kind of like, not a FOIL there, but I need to distribute x plus 2. Now, if I'm trying to make these match, that would mean that the second fraction needs an x, top and bottom. So I'm going to multiply top and bottom there by x. So my denominator that I'm going to use for my common denominator is x times x plus 2. Now, just to make it easier for myself, I would go ahead and just use that common denominator. This is over 1, so I need both the x and the x plus 2. But this is going to be nice for us because if we have an equation, if I can make all those denominators the same, then we can literally just eliminate that and focus on the numerator to solve the problem. Okay, now I'm just going to kind of simplify as I go here. So I'm going to distribute negative 2. So I'm going to get negative 2x. Negative 2 times 2 is negative 4. In between here, you're adding. When I add, I'm going to distribute an x. So I'm going to have x times 3x would be 3x squared, and x times that negative 4 is going to be negative 4x. On the other side, I'm going to distribute 3x. So that's going to become 3x squared plus 6x. Okay, let me just combine some like terms on the left here. So I've got 3x squared. I've got a negative 2x and a negative 4x, so that'd be negative 6x, and I have a negative 4 there. And I don't know if you guys noticed this. You're probably like, oh, I don't want to deal with the quadratic. Don't worry, you don't have to. Do you guys see there's a 3x squared positive on both sides? So if I try to subtract that to the other side to combine like terms, it's actually going to cancel out on both sides. So there's no 3x squared there. And I wrote too big with my giant handwriting, sorry. You have negative 6x minus 4 equals 6x. These 6x's don't cancel out. One's positive and one's negative. So actually, if I want to continue, I'm going to just add this 6x to the other side. Those do not cancel. You have negative 4 equals 12x. Don't write negative 3 as your answer. If I want to get x by itself here, I would actually have to divide by 12 to do that. So my answer is going to be a fraction. Negative 4 over 12, those reduce. What would that be? Negative 1/3. Yeah. Okay, now that is not going to cause me a problem. Numbers that would cause me a problem in my denominator would have been 0 or negative 2. As long as we don't get those as an answer, we're good. And that should be correct for that question. So negative 1/3. Does anybody have a question? Okay, that's pretty much all the algebra and simplification you're going to see from this unit. Everything else is going to relate to the graphs that we did, and there's one of each type. So the first type, this is just an inverse variation here. And what I have graphed is y equals 2 over x, but shifted. And what I'm going to ask you guys to do, see if you could write the equation and then tell me the domain and range for this graph. So, I'm just going to kind of highlight the asymptotes real quick here. It didn't come out great on my copy, just so you guys can see it better. So the vertical asymptote up and down, I call that vertexal so I can remember it. It's just x equals -2. And the horizontal asymptote, I call it horizontal. It's actually the same number. It's y equals -2. All right, now it's been a minute since we've graphed these, but if I have branches in quadrants 1 and 3, which is what I have here, 1 and 3, that is based on my asymptotes. That is going to tell me that the number on top of the fraction should just be positive. If we're in quadrants 2 and 4, that tells me the number on top of the fraction should be negative. So if I'm going to shift this, I'm just going to rewrite this so it has these asymptotes. I'm just going to write y equals, it should have a 2 on the top. Okay, now I'm moving 2 units to the left and 2 units down. So what would you put with the x in the bottom of the fraction if you're going 2 units to the left? Exactly. That's opposite of what it looks like, so it should be x plus 2. The x is going to go with the vertical asymptote. Okay, now if I shift it down 2, what should I put outside that fraction? Just -2. So opposite copy, and you guys can see that right here. So the problem number here, if I plug -2 into that denominator, that would cause me to divide by 0. That's why that's an asymptote, because I can't put in -2, so there's no graph there. So that's what you're seeing in the picture. And again, that number on top is +2 because of the quadrants I'm in. If I was in 2 and 4, then it would be negative. If they're diagonal from each other, you're just working with a plain x. If they're in the same direction, we'll do that underneath here. That's going to be an x squared. Okay, now you guys are going to have to forgive me on this. So in class, when I had you guys do the domain and range, just to make it so much easier, this one branch goes left forever, one branch goes right forever, and you just don't touch the number in between. So I had you guys just do all real numbers, but not -2, which is totally correct. Unfortunately, on the actual final, this will be multiple choice, so you won't have to write it out, but they give the options in interval notation. So I want to show you how to write it in interval notation. So this branch goes to -infinity, and it stops at -2. So to write that, you just write -infinity, -2, both parentheses, because I have an asymptote at the 2, so I don't, or -2, so I don't actually touch it. The other branch gets its own interval. Just put a little u in the middle. It's called a union symbol. This just means I have 2 parts to my domain. Now, this branch up here, if I'm traveling from left to right, this starts up again after I go over the asymptote, and it goes to the right forever. So it's just going to start up at -2 and then go all the way to infinity. Basically what that does is that just excludes -2. It's just a little bit different way to write it than what we were doing. Okay, now for this particular problem, the range is actually identical. If we were doing it in class, you're going up and down forever, but you don't touch here in between, which is also at -2 for this problem. And so the interval would be exactly the same. It's just talking about going up and down instead of going left and right. And that's not typical. Usually the 2 asymptotes are not the same number, so that's just for that question. All right, let me scooch over here. All right, now your asymptotes on this graph. You're going to have a vertical asymptote, call it vertexal, at x equals 3. And you're going to have a horizontal asymptote at y equals 2. If you look at the branches on this graph here, based on my asymptotes, this quadrant would be 2, this quadrant would be 4. So based on where those are at, what that's going to tell me, it's just going to switch that number on top to be -2. So all these graphs are a shifted version of y equals 2 over x, or 2 over x squared for the questions underneath. So the negative is what causes those branches to go in quadrants 2 and 4. Okay, now, if I'm shifting the graph here 3 units to the right, what would I put in the bottom of the fraction? X minus 3, exactly, opposite of what it looks like. And you guys can see, if I plug in 3, that causes the denominator to be 0. That's why you have an asymptote there. Now, this graph is going 3 to the right and up 2. So up or down, you're just going to put that outside the operation. In this case, we've got a fraction. If it's up to, it's just going to be plus 2 on the outside. Okay, now when I write my domain here, the only number I'm not touching is 3. So I'm going negative infinity to 3, both parentheses, put a little union symbol, and then we start up again on the other side of that asymptote with the other branch from 3, and then it does go to the right forever to positive infinity. For the range, that's up and down. The number I'm not touching on my range here is 2. So one branch goes down forever, one branch goes up forever. So this is going to be negative infinity to positive 2, union 2 to positive infinity. By using those parentheses, we're excluding the number 2, but touching everything else. All right, now the last two, these are both shifted versions of y equals 2 over x squared. Now, the x squared is what causes the two branches to go the same direction. They either both go up or they both go down. So I have one example of each to review this. And again, let me just draw my asymptotes in here real quick. So I have a vertex line at -4, and I have a horizontal line at 1. So my vertical asymptote x equals -4, horizontal asymptote y equals 1. Now, based on the branches here, based on my asymptotes, this would be quadrants 1 and 2. That's going to indicate to me when I write my equation that the number on top of the fraction is just going to stay positive. So I shifted 2 over x squared, so it's just going to stay 2. Now, the difference here when you write the bottom of the fraction, because we're looking at branches going the same direction, the bottom is going to be squared. We're not going to FOIL this or anything, but if I've got x equals -4, I'm going 4 to the left. I just write the opposite of what that looks like, so it would be x plus 4, but you just put a squared on that. That's all it does. The squared tells you the branches are not diagonal from each other, they're going the same direction. Everything else works the same way. And then here, for your horizontal asymptote, we're shifting the graph up 1, so the plus 1 goes to the outside. With the x, it's going to be the opposite of what it looks like, and then with the y, it's just going to be copied on the outside. All right. Domain here, I'm going left and right forever, but I'm not touching -4. To write that as an interval, we go negative infinity to -4, both in parentheses, and then union, start up again at -4 on the other side of the asymptote, and go to positive infinity. Now, the range is different for an inverse square because if I'm looking how this graph moves up and down, I am not touching any part of that graph till I hop over that asymptote, and then both branches point up forever. There's only one interval here. So I'm just going to start. The lowest y value is right after I hop over the 1, and then it's going to go up forever. So it's going to go up to infinity. All right, and then I got one more, and then we've covered all the different shapes of these graphs. All right, vertical asymptote here. X is 4. And the horizontal asymptote should be y equals 5. Now, both of these branches point down. Based on my asymptotes, these branches are in quadrants 3 and 4. So going the same direction indicates to me that I've got an x squared, and both going down indicate to me the number on top should just be -2 instead of +2. The negative flips that graph over. All right, then it's going to be x minus 4 squared. I'm 4 to the right. If I plugged in 4 to that denominator, that would cause us to divide by 0. So that's why we don't have any graph that's allowed to touch that. And then I'm going up 5, so a plus 5 on the outside. Now, in terms of your domain, you're touching every number except 4, left and right forever. So negative infinity to 4, then union 4 to infinity to write that. Now, on this one, the range. Whenever I do the range, I always go from the bottom to the top to write my interval. These branches both point down forever. So just one interval here, it's negative infinity. And then the branches are stopped when they get to the asymptote. There's no graph above that. So we're going to have negative infinity to 5. And then both parentheses there, that'll be our range. All right. Is anybody having a question?